Okay, so we continue. Compare and interpret two or more sets of group data based on appropriate measures of dispersion and hand max conclusion. Also, this is this part is more to HOTS. Okay, so daily life question and compare two sets of data. Okay, so let's see example 11. The table shows time taken by 20 employees in 2 factories to complete the job. So calculate the mean. Okay, so mean for factory A, mean for factory B, and standard deviation for factory A and B. Okay, so we're going to do this. Okay, for factory A, then standard deviation for factory A and B. Right? So then we can compare which factory's employee is more efficient, right? And justify your answer. So let's do it. So let's see factory A. So the mean. So this is tabular, right? So mean is, okay, 5 times 3, okay, is EFX times EF, so sum of frequency. So therefore is 5 times 3 plus 6 times 2, right? 6 times 2, 7 times 9, 8 times 2, and 9 times 4. Okay, over 20 employees. So 20. So each account factory, then 20 lah. So 3 plus 2, 5, 5 plus 9, 14, 14, 14, 18, 20, correct? So you get, so if you use your calculator, it's 15 plus 12 plus 63 plus 8 times 2, 16 plus 36. So it's 142 over 20. So it's 7.1. Okay, the mean is 7.1. For factory B, okay, factory B, so the mean is the same also, the formula, the sum of fx time divided by sum of frequency. So it's also 20 below. Okay, so above is 5 times 1, 5, and then 5, 6, 5, 30, 7, 7, 49, 8, 5, 40, and 9 to 18. All right, so you divide 5 plus 30 plus, sorry, 5 plus 30 plus 49 plus 40 plus 18. So divide by 20 is 7.1 also. Okay, so the mean is the same. So that means the mean, the time taken by the mean to complete a job is 7.1, same. So now we need to find the standard deviation. So the first thing we need to find is the sum of frequency times the data square. So here is 5 times 3. So it's 5 square times 3, then 6 square times 2, plus 7 square times 9, plus 8 square times 2, plus 9 square times 4. Okay, the sum of frequency. So later on we divide by the total frequency. So you get 25 square times 3 plus 6 square times 2 plus 49 times 9 plus 64 times 2 plus 81 times 4. So it's 1040. Okay, so the standard deviation is, we find the variance first, that is sum of frequency square, okay, time data square over the total frequency minus the mean square. So you get 1040 divided by 20 minus 7.1 square. So you get 1040 divided by 20 minus 7.1 square. So you get 1.59. Right, so the standard deviation is square root of 1.59. So is 1.26. Okay, so now we find the sum of fx squared for factory b. So you get 1 times 5 squared plus 5 times 6 squared plus times 8 squared. Okay, so you get 5 squared plus 5 times 6 squared plus 7 cubed plus 5 times 8 squared plus 2 times 9 squared. So you get 1030. So the variance is sum of fx squared divided by sum of frequency minus the mean square. So I get 1030 divided by 20 minus 7.1 square. So you get, of course, factory b is less, you see, 030 divided by 20. So you get 1.09. So standard deviation is 1.04. Okay, 1.04. Therefore, we can say that factory B employees are more efficient because of smaller standard deviation. Okay, so it's more efficient, right? So smaller standard deviation, more efficient, right? So let's go to number 2, dot spot. Okay, shows the distribution mass of tomatoes sold in factory A, supermarket A and supermarket B. Supermarket A. Okay, supermarket A and supermarket B. Okay, let's see, make it bigger. Can you see? Find the range, median, and interquartile range for the supermarket A. So A is, you can see here is, all right, let's use red color. Right, this one is the same. So the range is 212 gram minus 197. Okay, correct, not 197. Correct, 1 minus 197. So this is the range. So it's 212 minus 97. So it's 115 gram. Huh? So the interquartile range, okay, so interquartile range you can see here is, okay, first quartile is 202 minus 198. 202 minus 198. So it's 4, 4 gram. Okay, and then supermarket B, the range will be, okay, maybe I use green. The range will be 213 minus 197. So 213 minus 197. So it's 16 gram. Sorry, 16 gram. Huh? Okay, and then 212. Okay, this one is 15 gram. Huh? Sorry, this one 15 gram. Okay, so sometimes you need to double check. 15 gram. Maybe the calculator when I read is not correct. So interquartile range. Okay, so interquartile range you can see is 204 minus 199. Okay, 204 minus 199. So it's 5 gram. So which supermarket sells the metal that has more mass? Okay, more mass. So explain your answer. So more mass, then you can see, find the median. Okay, more mass, right? So this one you can see here 16.5. So you can see here the supermarket B, sell more mass, right? The tomato that has more mass. So, and then the median, you can see the median for supermarket B is 201 gram, and then median for supermarket A is 200 gram. Okay, so the median is greater also, and then the range also, right? So the range of B is 16, also greater than the range of A, that is 15 gram. Okay, so that means has more mass for tomato that factory, the supermarket A, B, sorry, supermarket B sells more tomato that has more mass. So we can see here, you can see here. Okay, so the median to here is 75%, 50%. 50% is more than 200 gram. So here is 50% is more than 201 gram. Okay, 201 gram. Okay, so here you can see here is 50%, right? So 50%. This part is 50%. So here to here 50%. So here to here 50%. So you can see here the mass is more, right? So now we go to talk spot 2, number 3. Okay, determine which student has a greater median of test score. Okay, which median? So you can see here Kavita now. Kavita. So the median is 76. So there is 76. So here is 74. This is 76. 76%. Okay. Who has the greater interquartile range test score? So let's see. So Kavita has a 80 minus the interquartile range is these two. So it's 80 minus 68. So it's 12%. Then Amin is 88 minus 68. So is 20% different. So who has a greater interquartile range of score? Amin. So that is 20%. Who has greater range of test score? So you can see range. So the range here is 96 minus 60. So it's 36. So the range for Kavita is 88 minus 56. Okay, 88 minus 56, so you get 32. So who has the greater range? That is Amin also. Okay, Amin has 32% of the range. So who has more predictable test score? Right. So who has a more predictable? So you can see here 50% of the score you can predict here. You can see the smaller range. So who is predictable? So Kavita. Okay, because of smaller range, right? And also interquartile range. Okay, so you can see here 50%, 25%, very easy to predict. So because of the smaller range and smaller interquartile range. So this one is more to negative, right? So the graph is some sort like this. Okay, so this one is more to let me see. Sorry, this one is more to correct. This one is more to here. Okay, so remember this. Okay, this one is higher here, right? So more, this one is more than this. This one is also the same. Okay, so this one is predictable right here. Right, more to the right side. This one is more to the left side. Okay. All right. So meaning that smaller range is more predictable lah. Okay. Question number 4. The table shows the marks obtained by Stan Jackson and Jack Finn in a 5 mathematics test. So find the mean and standard deviation of marks of and whose performance is more consistent. So if the standard deviation is smaller, then it's more consistent, right? So remember. Okay, so A, find the mean. Okay, so find the mean. I think you can do it by yourself. Mean. So 89 plus 65 plus 63 plus 66 plus 69 divided by 5. Okay, and then the sum of square, 89 square plus 65 square plus 63 square plus 66 square plus 69 square, right? Then the standard deviation is, okay, what is this? So you put in, okay? All right, B, the mean, or you just find the sum of x first, 65 plus 68 plus 63 plus 59 plus 75. Okay, so equals to, okay, let's do it. So if you know how to do this, you just stop the video and then you can check the answer later on, right? All right, so you do it by yourself first. Okay, this is sum of x, 65 square plus 68 square plus 63 square plus 59 square plus 75 square. Okay. Two 1924. Okay, so standard deviation 21924 divided by 5 minus the mean 334 over 5 square. So you get your answer lah. Divided by 5 and then you minus 334 over 5 square. Okay, hold on. Let me check any mistake. So it's 65.71. Oh, so big. Impossible. On a Okay, let me check. $5.36, I'm sorry. $3.67. All right. So okay, so this one is 330. Made a mistake here. So it's 2,124. Okay, correct. Huh? So this one is, all right, 59 plus 65 plus 63 plus 60. Okay, 352 over 5. So here is 89 square plus 65 square plus 63 square plus 66 square plus 69 square. So it's 2532. 232. So you put in here minus 352 over 5 square. So you get minus so you get 9.50. Okay, so you can see here who has more consistent B. So it's Jack Bin. Jack Bin is more consistent. Okay, because of smaller standard deviation. Okay, so never mind, let me check again whether my calculation is correct or not. Okay, correct. So meaning that Jackson not consistent because of the standard deviation is very big. Okay. All right. So can do for STEM 1, do the self practice at point 2E, page 235. So this is the recording video for at point, right? At point 2.5. Right, compare two or more sets of ungrouped data based on the appropriate measures of dispersion and hence make conclusion. So to summarize it, standard deviation, smaller standard deviation means smaller, more consistent, and also smaller range also tells you about the predictable or not predictable, right? Okay, smaller range and more predictable. Okay, and then this one is where's the mass? Okay, so has a greater mass, then you see the median and also the range also here. So more mass means the median is bigger and also compared to the others, and also the range is also greater than the others, right? So then you can conclude that the tomatoes, supermarket B sells more tomato, more mass, tomato with more mass than the supermarket A. Then question 4 tells you about the Jack's Bin is more consistent because of the smaller standard deviation. Okay, and then the mean, I think 230 divided by 5 is 66. So the mean for Jack Fin is 66, and 352 divided by 5. So, and then the mean for Jackson is 70.4. So although Jackson's score more, right? Mean the mean is more, right? But Jack Fin is more consistent, right? That is the difference between the mean from the data. That means the test score. Each test score is smaller compared to the mean, right? But Jackson is a bit frustrated. That means he's not so consistent. So you can see here, he can score 9.5, more 80 point something, or 90, 80 point something, and you can score 60 point something, right? But Jack Vin can score 61. The less is 61, and then the highest is 71. So it's the the difference is very small. The error here is very small. Error here means the data. That means the test score compared to the mean is very small, so it's consistent, right? So meaning that the smaller standard deviation more consistent, right? That's all.